So you just kind of have to bite the bullet. We know how to find the standard deviation, so we're going to do it. So to find the standard deviation, we first have to find the mean, and you add them all up. So that would be 13 plus x, and divide by how many you have. And so then you find how far each one of these is from the mean. So you subtract the mean from each of your values. And again, you just have faith it's going to work. And so then let's simplify these, just grabbing a common denominator of 3. 4 is 12 thirds, so 12 minus 13 is negative 1. That negative distributes, so minus x. 9 is 27 thirds, so 27 minus 13 is 14, and then minus x over 3, sorry. And then this is x is 3x over 3, so 3x minus x is 2x, and then minus that 13 over 3, and just getting a common denominator. So those are the differences from the mean. And then to find the standard deviation, you need these squared differences from the mean. So we're going to take all these and square them. And so if we do that, I'm getting 1 plus 2x plus x squared over 9. And that's 196 plus, minus 28x plus x squared over 9. And then this is, I'll just write it in the same order, 4x squared minus 52x plus 169 over 9. So 4x squared, Alright, looking good. And so now we found the squared differences from the mean. We need to take the average of those to find our variance. So to take the average, I need to add them all up. So they all are ninths, so I can add the numerators. They all have the same denominators. So combining like terms, I have 6x squared, then 2x minus 28 minus 52 is minus 78x, and 1 plus 196 plus 169 is 366, and that's all over 9. Ha! And then you can simplify this thing because these are all divisible by 3. You can do your little divisibility by 3 check. 7 plus 8 is 15. Since 15 is divisible by 3, that's divisible by 3. 3 plus 6 plus 6 is 9. 15. Since 15 is divisible by 3, that's divisible by 3. So if you take all of them and divide by 3, we can simplify this a little bit. Oh, God, they all divide by 6, right? Because I can simplify that even more. They all divide by 2 now. So that's minus 13x plus 61, and then not over 3 anymore, right? 2x squared. Oh, no, the bottom doesn't divide by 3. What am I doing? What am I doing? Those divide by 2, but that's not a 2. Wishful thinking. Anyway, so that was the sum of the differences, of the sum of the square differences. And so we're finding the average of those to take the variance. So to take the average of those, you are dividing by the 3 terms. So basically multiplying by a third. And so then you get 2x squared minus 26x plus 122 all over 9, which means that the standard deviation is the square root of this thing, right? So it's the square root of 2x squared minus 26x plus 122 over 9. Ha! So we found the standard deviation. But they told us that the standard deviation is supposed to be the square root of 14 over 3. We just have to solve this. So a nice way to tackle is, what if you rewrote 14 over 3 as 42 over 9? And so if the bottoms are the same, the tops must be the same. So 2x squared minus 26x plus 122 should equal 42. I see an end, right? It's a quadratic. We can solve this no matter what. Scoot the 42 over there. We get plus 80 equals 0, and then divide everybody by 2, and then factor, things that multiply to make 40 add to negative 13, that's a minus 8 and a minus 5. So by our zero product property, x could be 8 or 5. We did it! Either one works. The only one they list there is the 8, but both of them would work. And you could test this. You could take it with just the 4, the 9, and the 8, do all the calculations without all the crazy variables, and check that it works. All right, fun.